This is my school channel and my name is Abiola. For this video lesson, you are going to join me as we dig through the topic functions and relations. Okay, we are going to look at what function implies, okay, relations, what is the difference or the interaction between functions and relations. We are going to look at several kinds or different kinds of functions or relations and relations to both. And of course, we are going to consider, one-to-one mapping, onto mapping, composite mapping and the like. So you don't want to go anywhere because you are going to stay with us and we will be right back. Thank you for joining the My School YouTube channel. Right there, we are going to learn the topic relations. Okay, so under relations, we have function. So at first, you may ask, what are relations? Okay, so this is simply a connection, right? Relations involve connection or the interaction between two sets of values. All right, or you are looking at interaction between a domain and a co-domain. All right, so basically we have relations, where we map each input to at least one input. So this is where we have our inputs, right? And this is where we have our output. So that connection, right, between inputs and outputs, or that connection or that interaction where inputs are matched, okay, to at least one output, that is where we have relations. Okay, so we now have functions still like a subset of relations. So functions are just about rules, okay, that actually map a single input to a single output. So anything that is more than an output for an input, that is not a function. So let's do some examples here to understand the concept we are trying to look through. So we have functions, right? Map each input, it maps each input to exactly one output. So we have the element, then we have the image. All right, so one element, one image. Okay, so there are no twins, there are no quadruplets or the rest. So let's look through what functions are or what are not functions. So we have this, we have one-to-one. All right, these are kinds of relations. So we have one-to-one relations or one-to-one mapping. So we can see one-to-one, just like the name implies, one to one. All right, so one element to one image. One element to one image, one element to one image, or one input to one output, one input to one output. So each input maps to a distinct output. So this, of course, is a function. All right, so we can say that all functions are relations, okay, but not all relations are functions. So we are going to run a confirmation of that as well. So we have another kind of mapping or another kind of relation. Okay, so we have many to one. Okay, so we have multiple inputs mapped to the same output. All right, so we can see this to this, this to this, this to this. This is, of course, an example of a function. Why is it a function? The inputs, all right, they just have one image. All right, so one input to one image. So right here, it is possible that we have two inputs that are actually sharing the same image. But the consistent thing about functions, okay, should be that the inputs do not have more than one image per head. Do we see that now? So this is, of course, a very good example of function. So let's see this. This is not a function. Why? Look at this. Map some inputs to multiple outputs. So we are seeing that an input is having more than an image, all right, more than one image. So look at this. This is good, but look at this. All right, so you can see this particular input is producing two outputs here and here. So that is inconsistent with the concept of functions. So once again, we can iterate or run a confirmation that all functions are relations, but not all relations are functions. Let's move on to the next slide. So furthermore, we are looking at relations. A relation shows a relationship between two values, right? So this is your domain, this is your co-domain. So what is a function once again? A function is a type of relation, right, where each input has only one output. This is just to further elaborate what we've looked into earlier. So look at this. All right, so this is one-to-one. You can see one input to one output, one input to one output, one input to one output. So one-to-one is a very good example of function. So let's look at the next one. We have many-to-one. So the consistent thing should be that each input produces only an image, all right, one image per input, okay, one output per input, all right, to put it that way. So you can see this produces this produces this produces this, and this produces this. This is very consistent with functions. So let's look at other types of relations that are not actually functions, okay, but they are of course relations. Okay, so look at this. We have one to many. So you can see that the input here or the element here is producing more than an image, all right. So you see, so this is not a function. This is of course a very good example, a good type of relation, but it is not applicable to be named or identified as a function. So we have this here, many to one. So you can see we have the input here is given, you can see, so you can see this as well too, is producing, okay, so you can see this, so many to many. So you can see the inputs, right, they are producing more than one image, so that is many to many kind of relation. So let's move further in our video lesson. Of course, this is just to identify certain terms that are very salient when it comes to relations. All right, so look at this. Domain. So we have domain, we have range. So where the inputs are coming from, that is where you identify as your domain. All right, so where the outputs are being made or being packaged, that is where you identify as your codomain. All right, so the images produced by the inputs or by the elements, right? Okay, you have them right here. So those images, you can identify them or name them range. All right, so it is possible that the images you have here, right, they are not actually a product of any inputs. All right, so that means that they are not in range. All right, so range is just talking about images that are actually there because there is an output, right? So that is what we are looking at right here. So range is not like a subset of the codomain. All right, so it is possible that all the images we have here, right, or all the members or all the elements we have here, or the outputs we have here, they are actually products of the input from here. But it's also possible that the range on this particular note right here, you can see the range consists of only images, all right, that are products of inputs. So let's look at this thoroughly. So if I'm asked to identify the range here, it will consist of this. So the range should include 0, 1, 4, 9. Okay, so it's excluding -1 and -4. So if you can run a trace, look at this. So we can see how it links. All right, so this is a very good example of expression that we should know about. So let's move on to the next slide. So this is just another illustration regarding domain, range, and codomain. All right, so we can see how will you identify or what kind of function is this? This is one-to-one function, right? Each input, one output, each input, one output, each input, one output. You can see that as well. So you can see right there that the range that we have here consists of all the members, right, in the codomain. All right, so this is of course very valid. So we can express our function in different ways. So you can see this is your independent variable, right? Because it is the value that we supply here that will determine what we will have as our image. Do we see that now? So we can read this as the function x, right, or the function f of x, right, is mapped onto this value. All right, so if x is taken as 3, so that will be 3 plus 1, that gives you an image of 4. So when the input is actually 3, the image produced will be what? 4. All right, so you can see x maps to this value, x plus 1. So let's move ahead in our slide. So with our slide, so we have function representation. So how can function be represented? So we can represent function using set of ordered pairs. Okay, we can use, this is identified as arrow mapping. All right, so we can use tables to represent our function. Okay, so we can use function notation, we can use graphical method, we can also use parallel axis to represent our function. So let's look at this together. So we have the function or the interaction. You know, we said function is about rules, right? So the rule that guides this particular expression is the fact that the function f is 2 times a number plus 5. So let's look at the first input, that is -4. -4 times 2, that is -8, plus 5 produces an image of -3. Do we see that now? Okay, so -2 times 2, that is -4, plus 5, that is +1. So that is how, so this is the rule that determines the function that we have right here. Okay, so we can see what is happening. So this is arrow mapping. right, to represent a function. This is tabular mapping to represent the function. Just the same thing, -4, -3, -2, 1. You can see 1, 5, 9, like that. 0, 1, 1, 5, then -2, and then 9, -2. That's an omission, please. All right, so we can see graphical representation. So you can run a trace. When x is actually -4, y is -3. When x is -4, so maybe we take it somewhere around there, y is -3, so we can see the linkage. All right, so that is how the graph came to be. So of course the function can be packaged in ordered pairs. So we have, you can see the input and its output, the input and its output, or you can say the element and its image, element, image, element, image, element, image. Then you can use it to produce any one of these. So you can see this is where it is being used in notation form. So let's move ahead to the next slide. So right here we are talking about representing function using parallel axis. It's just very simple. So you can see this, okay, contains your domain, and this is your co-domain. So right here in the co-domain we can determine what our range is. All right, so you can see this is the inputs, we have the outputs. You can see inputs, outputs, inputs, outputs. The same thing happens here. So this is another way that you can use to represent function. All right, so let's move on to the next slide. Okay, so we are just trying to refreshing our memory, right, regarding relations. So we have different kinds of relation. So you can see we have one-to-one relation. Just like we said earlier, you know, it means one input to one output. So 1 to 4. So we have one-to-many. So one-to-many means a single input is producing at least 2 images. All right, so this is of course not a function, but it's a relation. Do you get that now? So that is one input to many outputs, so that we have one to many. So look at this, many to one. So you can see that a particular image, right, is a product of at least 2 functions or two elements to put, or 2 members or 2 inputs. You can see, so you can see this and this actually produces this. All right, so this is many to one. So many or more than one element is producing the same image. So many to one. So we have many to many, whereby, okay, you can see from here, the input here is producing more than one output. You can see the same thing is happening. So it's occurring from both sides, you know. One input is producing one output, while an output is a product of many inputs, just like that. All right, so that is what happens here. So let's further understand these concepts before us. So how do we identify functions? So that is just a kind of a building block or a sketch of what it should look like. So we have our identifying function. So we have one-to-one relation. All right, so you can see A is being mapped to C, right? This is arrow mapping, isn't it? So this is the input, this is the output, or you can see this is the element and this is its image, right? This, then this, okay? So you can see that. So just like we identified earlier, many to one relation. So you can see all of this that we have here, right, is pointing to a single image. So many inputs are actually pointing or mapping to just a single image. So that is many to one function. Of course, we can also identify this as constant mapping. We are still heading for that direction, so do not go anywhere. So we have a one-to-many relation. So you can see this, we have one pointing to many relations. So one input is able to produce more than one image. So you can see A produces C and D. All right, we see that. Then we have many to many, just like I identified earlier. So you can see the input A is producing more than one output. You can see this is producing more than one output, this as well, just like that. And you can see from here, the effect is being noticed. So let's move on to the next content. Yes, so this should be an identification for one-to-one mapping. All right, this is a very good example of function. So this is a relationship, right? This is a concept that we are looking at that gave birth to this. So when x, right, when the input is -2, what would be our image? We can run our calculation. That will be -2 times 2, that is of course -4. So -4 minus 3, that is -7. All right, so we can see what we have here. So this is our domain where we have our inputs or elements. Then this is our co-domain where you have our range. So you can see all of the images we have here, they actually serve as the range for the inputs that we have right here. So this is a very good example of one-to-one mapping. So let's go to the next kind of mapping. So we have the onto mapping or the onto function or the suggestion. All right, so the first one that we have as one-to-one, we can refer to it as injection. This is actually surjection. So a surjective function or onto function is a kind of function whose range is the whole of the target set. So that is, there is no item, right? There's no item in the code domain that does not serve as an image to at least one input. Right, so it tells you that, okay, every item you can find, right, in the code domain is actually a product of an input. So that is why we have onto mapping. So you can say a function of this, so function A, function F, okay, of A maps B is onto if and if, right? So just this is what we have here basically. All right, let me not bore you off with this concept. So look at this. So you look at all of the items we have here. They are the range, right? All of them, all of the range that we have here, right, they are actually a product of an input. So look at this. So none of them is lying fallow or useless, right? So that is what we refer to as a surjective or an onto mapping. So look at this. This is of course a function, but not an onto function. Right, look at this. So you can have, you see, we have other elements that we have right here that are not actually images of an input, or that are not output of an input. So this is of course a very good type or example of relation, but it is not an onto or surjective mapping. So let's move on to the next slide. So we have the identity function. It's just like you are creating an exact replica of yourself. So just like a twin set. All right, so you can see this. We have 1 is being mapped to 1, 2 is being mapped to 2, 3 is being mapped 4 to 4, and then 5 to 5. So just like the term implies, right? Identical twins, you know, they look exactly the same thing. So this can take the position of this as a domain, and this comes as a code domain, and nothing changes. All right, so you can see that right here we have one-to-one mapping, right, for identity function. We also have onto mapping because all of the images we have here, they're actually products of at least an input. So for an identity function, one-to-one mapping is happening, onto mapping as well is also happening, and all of the range, right, they are functional, right? So let's move on to the next slide. So very well, we have constant function or constant kind of mapping. Okay, that is a situation whereby all the elements, all the inputs, they all just produce exactly the same image, right? So it's just like you saying all the students in a particular local government, they are attending a particular school, probably a government school. So all the children probably under the age of 10, right, they are attending a particular primary school. Let me say a government, a primary school that belongs to the government, a community primary school, a community school. So you can see all the children in the particular. So all the inputs we have here, they are attending or they are producing just a singular image. So the range is just a singular item. Right? Okay, so that is what we refer to as constant function. So you can see this is the map, right? This is also an example of arrow mapping, you know, how you can express your function. So we have your domain, we have your co-domain. So you can see the constant. This is referred to as the constant. So you can see the range. So the range is actually a singular image, right, for all the inputs from the domain. That is what we refer to as the constant function. Let's move on to the next slide. So this is just a further example of a constant kind of function. So look at this. We have the input, the input, the input. All of them just produce a singular image, E. That is your range. All right, so you can see the function f such that x, right, is mapped onto y. All right, your domain, your codomain. So your range is just a singular item. Let's move on to the next slide. Yes, so we have the composite function. A composite function is created when one function is substituted into another function. You know, when you recall your substitution method, right? So look at this example closely. So we have for x, right? So we have the function f of x, then we have 3x plus 2. So this is your input, right? This is the image that we want to, once we use this to derive an image, then this is for g, right? The function g, this is function f, function g. All right, so if you have f of g of x, you can see what we are going to have here. So you're actually substituting the value. So anywhere you see x right here, what do you use to replace it? Replace it with the g, what g carries. So this is the expression for gx plus 5. So anywhere I see x inside f, I'm going to put x plus 5. That will be 3 into brackets x plus 5. then plus this 2 that is line. So it's just a kind of substitution function. All right, so that is for composite. You are just substituting value. So when it is g of f of x, so that is just what are the values of this? What are the expressions for this particular input? That is 3x plus 2. So this will not just be an ordinary x. This will be 3x plus 2 plus 5. Do we see that now? We use that to produce an image. So of course it can be more than 2 sets, right? We can have 3, right? Whereby a situation whereby a particular domain, right, is linked to another, which is the codomain, then we have another. All right, so that of course happens in the composite function. As we move further in the video, I'm going to produce examples whereby we are going to solve questions relating to 3 sets of values under composite functions. Let's move on to the next slide, please. Yes, so this is of course referred to as an inverse mapping. So in inverse mapping, what you are just doing basically, I just want to put this in the simplest term possible, is that you are just swapping the position of the domain for the codomain. So look at this. We have A, input A produces the image 3, this produces output 1, this produces output 1. So the inverse, just like saying the inverse of 2 is 1 over 2 or is 0.5, isn't it? So the inverse of 3 is 1 over 3, okay, or is 0.3. So the inverse of this particular function will just be a swap. So you can see right here now, this that has always been the range, right, they are now becoming the domain. So what has always been the domain, they have now become the range, right? So where you have the position of the codomain is being swapped for the position of the domain. So that is basically about inverse function. This is where the short video lesson ends. All you just need to do is to click on the link in the description below. This is going to get you to the My School website. So right there you get to hit the subscription button. All right, so do not forget to always hit the like button for us. Do not forget the subscription button, and always tap on that bell notification for you to get informed immediately we upload the next video content just for you.